Hi, this video will show a method to analyze electric circuit powered by DC source. In this circuit we have two independent loops, and to solve the circuit, first you got to assume the current direction in each branch. So in this case, we'll say that the current in this branch is I1, and of course it will be the same current in the same branch. It means the current I1 flows in the battery E1 and in the resistor R1. That's I1. Let's assume the current in the other branch I2. Let's say it's I2 in this direction. So it will be the same thing, I2 in this one. Okay. And in the other branch, the third one, will assume there is current I3. So I3 will be flowing in the resistor R2 and the voltage source E2. Okay, so make sure that every element has current, assumed current. So we have I1 and I2 and I3. And remember that the current is the same for all elements connected in series. What's required? It's required to find the currents in every element and the voltage across any element. To start the analysis, first apply Kirchhoff current law. So Kirchhoff current law will be applied at each node. In this case, we have only one node, node C. So in this node, we'll say that the current I1 entering C and I2 and I3, they are out of the node C. So we'll say the sum of the current in equal the sum of the current out. So I1 will be equal to I2 plus I3. Arrange this equation in a way that the all unknown will be in one side. So you have I1 minus I2 minus I3 equals 0. That will be the first equation. That's equation number 1. If you have another nodes where the current is distributed, you should write the equation for this node. But in this example, we have only one node C, which is the current is divided. Second step, start writing Kirchhoff voltage law for each independent loop. In this case, we have two independent loops. The first one, this loop A, B, C, D, A. It's a closed loop. That's the first one. You write Kirchhoff voltage law for this one. The second independent loop is D, C, E, F, D, another closed loop. So we have two independent loops. We'll write the Kirchhoff voltage law for each one. Let's start with the first closed loop, which is A, B, C, D, A. How you write the Kirchhoff voltage law? To do that, you got to define the polarity of each element or across each element. So this is positive and this is negative given. For the resistor R1, the current I1 is flowing in this direction, so it will be flowing from the positive to the negative. In R2, we have I3 flowing in this direction, so the polarity of the voltage across the resistor will be positive and negative in this way. And this voltage source, it's already given. So we know that in any resistor, if you have any resistor R, and the current flowing in this direction will be flowing from the positive to the negative polarity. That's the way that you define the polarity of the voltage across any element. Second, to write the Kirchhoff voltage law for the loop A, B, C, D, A, you got to define the first polarity you're going to face. What do I mean by that? If we say that we're going to move in the clockwise direction and we're going to start from E1, so the first polarity you're going to face the negative. And then when you move up to R1, that's the first polarity you're going to face, mark. And then move R2, that's the polarity of the voltage, the first one you face. And E2, that's the first polarity. So once you circle these voltage, you start writing the equation. We start by E1. Should we always start with E1? No, you can start any element. I just start from E1, so it's negative. So I write negative E1, which is negative 6 voltage. Then you move to the second element. It's a positive. What's the voltage here? It's R1 times I1, 2 ohm times I1. So plus 2 ohm times I1. Next, the element R2, you have I3. You multiply R2 by I3. R2 is equal to 2 ohm. So say plus 2 ohm times I3. Next, you have E2, 4 voltage, and then you are passing by the positive voltage. So P plus E2, which is equal to 4 voltage, will be equal 0. That's Cursive Volts Law. Simplify the expression. Negative 6 plus 2I1 plus 2I3 plus 4 equals 0. Continue the simplification process. So you have 2I1 plus 2I3, and then you have negative 6, and plus 4 will be negative 2, equals 0. Rearrange the equation in a way the all unknown variables on the left-hand side and the numerical values right-hand side. So you have 2I1 plus 2I3 equal 2. Remember, the unknowns in this circuit, 3. They are I1 and I2 and I3. Always rearrange the equation in this order. So you have 2I1, the first element. You don't have I2, plus 0. I2 plus 2 I3 is equal to 2. So I wrote the equation in a way to keep the order as we explained here. So that's the first closed loop. Then apply Cursive Volts Law in the second one. So in this circuit, you get to do the polarity. How you define the polarity? The same way. You just say, I'm going to move in this direction, clockwise direction, we agree about. And start to put the polarity on this side. Not to confuse you, I'm just going to erase the old polarity that I did here, especially on this side. And then when you are moving in this direction, clockwise direction, that's the positive and that's the negative. The first one you face when you move in this direction, the first polarity you are going to face is the negative. And then you have I3 passing through 2 ohm. The current passes from the positive to the negative. And when you are moving in clockwise direction, this is the first one you're going to face. I2 passing in R3. That's the positive, that's the negative. This will be the first polarity you're going to face. Then you move, that's the negative, and that's the positive. Circle the first polarity you're going to face when you are moving in the clockwise direction. Then you start to write the Cursive Volts Law for the loop D, C, E, F. So the Cursive Volts Law for D, C, E, F, D. You start with D, you end with D to make sure that you close the loop. Let's just take it one by one. Let me write the equation here and then copy. The first thing, you have negative 4 voltage. This is the one, negative 4. So you write negative 4. And then when you move, you are going to face the negative 2 ohm times I3. So you have negative 2 ohm times I3. move in the clockwise direction, you're going to see the positive. That will be positive 4 ohm times I2. And then continue. Then you face the negative voltage of 2 voltage. That is equal 0. So that's the equation of the second loop. Let's make a copy of this one and take it there. And we're going to simplify the expression. So you have negative 4, negative 2I3, positive 4I2, negative 2 equals 0. Simplify. Negative 2I3 plus 4I2, and then you have negative 4, negative 2 is equal negative 6, equals 0. Rewrite the equation in a way, as we explained previously, you have I1, I2, I3 in this order. So the final equation is 0I1, because we don't have I1 in this equation. I2, it's plus 4I2 minus 2I3, and negative 6 go to the other side of the equation will be positive 6. So that's equation number 3. So now we have 3 equations in 3 unknowns. That's the first, the second, the third. And the unknowns are I1, I2, I3. Rearrange them in a matrix form. So I say I1, I2, I3. The unknowns. And that's the coefficient matrix. And that's the column vector. How do you write the equations in compact form? The first equation, let's just take a copy of it. So what you are going to write in this matrix, just arrange it, say that I1, I2, I3. Why this order? Because this vector I1, I2, I3 just right here in the top to remember what the coefficient I'm going to write in each cell here. This is, I write first equation, second equation, third equation. For this equation number 1, you have I1 coefficient 1, so I put 1. I2 has coefficient negative 1, I3 negative 1, equals 0. So I'm done with the first equation. Now I'll go for the second equation. That's the second equation. I1 has coefficient equal 2. I2 has coefficient 0. I3 coefficient 2 is equal to 2. Now I'll go for the third equation. The third equation, I1 has coefficient equal 0. I2 has coefficient equal 4. And I3 negative 2. And the constant terms equal 6. So you have the 3 equations rearranged in a matrix form, and we're supposed to solve this equation. You can use any program like MATLAB, or you can use your calculator to calculate the value for I1, I2, and I3. For example, I did use MATLAB, and to do MATLAB, so you first type the matrix 1 space negative 1 space negative 1 semicolon, and then the second row 0 space 0 space 2 semicolon 0 space 4 space negative 2, and then you write the other vector. I will just call it V, which is the one to the right here, 0, 2, 6. How you write this one? Say 0 semicolon 2 semicolon 6 and semicolon not to blend. Then how you solve this equation? Well, if you look at this equation, I call this matrix, I call it R. I call this one I call this one V. So I just write like that, R times I equal V. find I, so I would say I is equal the inverse of the matrix R times V. How I do it in MATLAB? I would just write I equal the inverse of the matrix R times the column vector V, and then I type the result. I did that, and then that's what I got. Of course, that's not the only way to solve it. You can use your calculator to solve three equations and three unknowns. Excuse me. So what you got here, the first element is I1, and this is I2, I3. Why? Because I rearranged the equation from the beginning. That's I1, I2, I3. So you can write that the solution, I1 is equal to 1.2 amp, and I2 is equal 1.4 amp, and I3 is equal to negative 0.2 amp. When you get negative value, it means the direction of the current you assumed in the beginning, it's in the opposite direction. So I assume in the beginning I3 is flowing in this direction, downwards. So that's not the right direction. Since I have negative, it means that the current is going upward, not in this direction that I assume. So if you can sketch it here, you will say that R3, which is equal to 2 ohm, and you assume that I3 going in this direction be negative 0.2 amp. You can keep it as it is, and then you get any required question. But let's say that you want to find in the right direction. So let's say the current actually flowing in this direction, and the value is equal to 0.2 amp in this direction, and then we make voltage drop this one. Why? Because the current would be flowing in this direction. It flow from the positive to the negative. So if you are asked to find the voltage across R3, so we say that the voltage across R3, according to this polarity that I assign to R3, you say I3 or negative I3, which is equal to 0.2 amp multiplied by the value of the resistance, which is 2 ohm. So you get 0.4 voltage. So that's the voltage across R3. You can solve any question in the circuit after you find I1, I3. If you want to find, for example, the voltage across R3, you multiply I2 by the R3. 4 ohm times I2. I2 in this case, we have that's I2 is equal 1.4 amp. You multiply it by 2 ohm, you get the voltage. So what I'm trying to say that once you find the value of the currents in each branch, you can find the voltage across any element. That's all. I hope that you understand. I will give you class practice to practice this one.